Hi friends, in this video we are going to learn about express the quadratic form in matrix notation. So here this is the quadratic form in 4 variable x1, x2, x3, x4. This is the quadratic form in 3 variable x, y, z, and this is the quadratic form in 2 variable. So here corresponding to this matrix we get the matrix of 4 cross 4 order. Corresponding to this quadratic form, here the quadratic form in 3 unknown x, y, z, so we get 3 cross 3 matrix, that is square matrix. And here corresponding to this third, here x and y are the unknown, so we get second 2 cross 2 matrix. So here how to write the matrix notation corresponding to this quadratic form. So here I want to write the quadratic form in terms of matrix notation. So here first I will write, so first I will solve this example. So here example 3. So here answer for 3. So how to write the matrix notation of this quadratic form? So here we have two unknown x and y. So first write here matrix of order 2 cross 2, a11, a12, a21 and a22. So here this is the 2 cross 2 matrix a11, a12, a21, a22. So here observe one thing. So corresponding to 1, here we have the unknown x, and corresponding to 2 we have the unknown y. Here, so the matrix notation of this quadratic form is the matrix notation of quadratic form is here q equal to here x transpose a and x. So here x is the column vector with coordinate x1 and x2. So here x transpose is the row vector. So here first I will write x transpose, that is here let's say in terms of x and y. Here let's say this is x and y, and here I want to write this coefficient matrix here, and this is my x and y. So here how to write this coefficient matrix? So here this is my matrix A of order 2 cross 2. Here just for your sake of understanding, here I am writing 1 is corresponding to x and this 1 is corresponding to y. So here 1 is corresponding to x and 2 is corresponding to y. So in this matrix, in the first row a11, a12 means here 1 is fixed, here I position is fixed and j is changing 1 and 2. Now come to the here second row, I is fixed 2 and j is changing, here a21, a22. So here in the same way, here this is the matrix, here coefficient of here x, here a11, so coefficient of x, coefficient of x and x, so coefficient of x square. Now this is the coefficient, so here coefficient of x, here coefficient of xy. Here x is same, y is x first coordinate, that is here 1 is same, means x is same. Here this is 1, this is 1 first coordinate. So here coefficient of x square. Here coefficient of x and second is here corresponding to this is coefficient of y. So whole divided by 2. So here now a1, this is a12 position. Here in the quadratic form a12 is same as a21. So write this same here as it is. That is now in the second row we can observe one thing. Here 2 is same. So here coefficient of yx, but here coefficient of xy is same as yx. So here I am writing coefficient of x y divided by 2, and this is coefficient of y, that is y square, coefficient of y square. So here this is the matrix notation in terms of two variable x and y. So here which is equal to x and y, which is equal to here coefficient of x square is, so coefficient of x square is 1, coefficient of xy minus 6 by 2, that is minus 3. Here coefficient of that is again minus 3. Here coefficient of y square 1. So here this is the matrix notation, and here this is x and y. So here this is the matrix notation where a equal to right here 1 minus 3 and this is 1. So here this is the matrix notation of the quadratic form q equal to x square minus 6xy plus y square. So here in this way we can write the quadratic form in terms of matrix notation. Here in this quadratic notation here a11 coefficient of x. Here a12 whenever you have cross position, so divided by 2, coefficient of xy divided by 2. So here a21 cross, here 2 and 1, I is not same as j. Here coefficient of yx is same as coefficient of xy, coefficient of y square, here y. So this is xy, this is row vector. So here this is the matrix notation of this quadratic form 3. So here this is the matrix notation of this quadratic form 3. So this is the answer. Now I want to write the matrix notation corresponding to this quadratic form. So here please write, pause and write. So now I will write the matrix notation corresponding to this quadratic form 2. So here I hope all of you written. So now here, so third example is solved. Now here I will solve second example. Now this is the quadratic form in x, y and z variable. So here first I will write matrix notation. Here first I will write here matrix of order 3 cross 3 for your sake of understanding. A11, A12, A13, A21, A22, A23, A31, A32 and A33. So here this is the 3 cross 3 general matrix. Now I want to write the matrix notation corresponding to this quadratic form. Here in first row, here A11, ith position is same. So ith row A11, A12, A13. Here this is fixed. So here 1 is corresponding to, here 1 is corresponding to x, 2 is corresponding to y. Let's say z is, let's say 3 is corresponding to, let's say z. Here x is same. Here x is constant and y is changing. Here let's say here I will write x, y and z. So here xx, xy, xz. Now here y is fixed. Here y is 2 fixed. Here I will write y. Here yx, yy, yz. Here z is fixed 3. zx, zy, zy. That is zz position. So here I will write. Therefore the matrix notation is answer for this. Here answer for this. Here matrix notation of quadratic form Q is, here Q equal to, here x transpose A x. So here x is the column vector, x having x y z. So x transpose is the row vector. So here I will write x, y and z. So here this is the coefficient matrix. Here I will write, and this is the column vector. Let's say here x, y and let's say z. So here how to write? Here this is, here coefficient of xx. So here I will write coefficient of, here x square. Here x is same. Now coefficient of xy. Here coefficient of, here coefficient of xy by 2. Now here this is 1 2 position. Here xy. This is 1 3 position. Coefficient of xz. Coefficient of xz divided by 2. So here first row. So here first row x is same, y is same. Here first position is same, that is 1. Here a11 is axx. Sorry. Coefficient of xx, x square. Coefficient of xy. Coefficient of xz. Now here in second row y is fixed. Here coefficient of yx is same as xy. Here coefficient of yx, but here I want to write coefficient of yx here, because here yx 2 1. Here coefficient xy is same as yx. Here divided by 2. Here coefficient of yy. Coefficient of yy, that is y square. Here coefficient of y and this is z, that is a2. Coefficient of y and z. So divided by 2. Now this is a31. Coefficient of zx. Coefficient of zx same as coefficient of xz. Here this is same as coefficient of, this is zx, but here this is z into x. But here coefficient of a31 is same as a13. That's why here I am writing coefficient of xz by 2. This is coefficient of zy. Here this is z and y. Here from here z, from here y. So here coefficient of, here zy, but here a23 is same as a32. That's why I am writing coefficient of yz by 2. So here coefficient of zz. So coefficient of, here zz, that is z square. So here this is equal to x, y and sorry x y z, and here now write the matrix. Here coefficient of x square 2, coefficient of xy minus 2 by 1 minus 1, coefficient of xz 6 by 2, that is 3. Here coefficient of xy minus 2, that is minus 1, coefficient of y square, that is 3, coefficient of yz, coefficient of yz is minus 10 divided by 2, that is minus 5, coefficient of xz, that is 6 by 3, that is here 6 by 2, that is 3. So coefficient of yz, here is coefficient of yz minus 10, that is here minus 5, coefficient of z square, so here so that is I think coefficient of z square, here so that is coefficient of z square, so this is minus 5. So here this is the matrix notation corresponding to the quadratic form. So here x y z. Now therefore A equal to, here write matrix, here 2 minus 1 3 minus 1 3 minus 5 3 minus 5, and this is minus 5. So here this is the matrix corresponding to this quadratic form, 2 having unknown x, y and z. So here this is the way to write the matrix notation of the quadratic form. So here this is the matrix notation of your quadratic form, where A is this. So here now I want to write the quadratic form of this one, that is quadratic form here x1 x2 x3 x4. So I got 4 cross 4 matrix. So how to write the matrix notation corresponding to this? Here I will write. Please write, pause and write. So here now I want to write, here I want to solve this first equation. Here I want to write the matrix notation corresponding to this quadratic form. Here number of columns are 4. So that is, here I got 4 cross 4 matrix. Here A11, A12, A13 and A14. This is second row. A21, A22, A23, A24. This is A31, A32, A33, A34. This is A41, A42, A43, A44. So here corresponding to 1, so I have corresponding to 1 I have x1, corresponding to let's say x2, corresponding to 3 x3, corresponding to 4 let's say x4. So here do one thing, write here x1, x2, x3 and x4. Write here x1, x2, x3 and x4. Here first row x1 is remains same, a11, a12, a13, a14. So here the matrix notation of this quadratic form is, here matrix notation of quadratic form Q is Q equal to x transpose A x. So here number of columns are 4. So this is the column vector having coefficient x1, x2, x3, x4. So this is the row vector having entry x1, x2, x3, x4. So here I will write which is equal to, here x1, x2, x3, x4. Now write the coefficient matrix. Here I will write, here this is the coefficient matrix and this is eigenvector x1, x2, x3 and x4. Now how to write this matrix? Here coefficient of, here x1 into x1 square. Here coefficient of x1 square. Here cross position a12. So here this is x1, from here x2, coefficient of x1 divided by 2. So here coefficient of x1 x2 divided by 2. So here this position, from here x1, from here x3, coefficient of x1 x3 divided by 2. So from here, so here I will write. Now here this is coefficient of, here x1 x4 divided by 2. So here, so this is x1 x2 x3 and x4. So here now second row, here x2 x1, here coefficient of x2 x1, but x1 x2 is same as x2 x1. Here I am writing x1 x2 divided by 2. Here coefficient of x2 square, coefficient of x2 square. Here coefficient of x2 x3. Here this is x2, from here x3. So here coefficient of x2 x3 by 2. Here this is x2, this is x4. Coefficient of here x2 and x4 divided by 2. Now come to here. Here this row, third row, x3 x1. But here a31 is same as a13. So write here coefficient of here x1 x3 divided by 2. So here second x3 x2. x3 x2 is same as x2 x3. So here coefficient of here x2 x3 divided by 2. Here x3 x3, coefficient of x3 square, coefficient of x3 square. Now x3, here x4, coefficient of x3 and x4 divided by 2. So here 4 1, x4 from here x1. So here coefficient of here coefficient of x4 x1, that is 1 x1 comma right here x1 x4 divided by 2. Why? x4 x1 is same as x1 x4. So this is here, right here coefficient of x4 x2, that is x2 x4 2. Coefficient of here x4 x3 divided by 2. Here coefficient of x4 square. Here observe one thing. So these are the diagonal position. x1 square, coefficient of x1 square, x2 square, coefficient of x3 square, coefficient of x4 square. This is my a12 position. Here a12 position is the cross position of a21 position. So these positions are same. This is my a13 position. a13 is same as a31. Here this is my a13 position. This position is same as this position. This is my a14 position. a14 position. a14 position is same as a41 position. So this is x1 x4 is same as this. Now here this is my a23 position. Here this is my a23 position is same as a32, cross positions. a23 is same as this. This is my a24 position. This is same as a42 position. So this is my a3 position, a34. This is same as a43. So here along the diagonal you make one line. So make one here right, and then fold this. So here then fold this. So here this is swapped with this. This one is swapped with this. This one is swapped with this. Here this one is swapped with this. This one is swapped with this. This one is here swapped with itself. So here this is equal to right here x1, x2, x3 and x4. Now here write the matrix. So here I will write the matrix. Coefficient of x1 square 1. Coefficient of x1 x2 by 2. Coefficient of x1 x2 is minus 2. That is minus 1. Coefficient of x1 x3 4 by 2. Coefficient of x1 x4, that is minus 2 by 2, that is minus 1. So here coefficient of x1 x2 same. Here this is same as this. So here these are the opposite position. So here along the diagonal. So swap. Here this is x2 square. This is 2. Coefficient of x2 x3. Here x2 x3 is 4. That is 2. So coefficient of x2 x4 minus 6. That is minus 3. Coefficient of x1 x3. So here this is swapped with this here, but here I will write coefficient of x1 x3, that is 4 divided by 2. x2 x3. So here x2 x3 is 4 divided by 2. x3 square, that is 3. Coefficient of x3 x4 minus 8 divided by 2 minus 4. Here x1 x4. So here this position is same. So here this position, that is minus 1. Here this is x4 x2, but here x2 x4. Here x2 x4 is this position. So here this is swapped with this. So that is x2 x4. x2 x4 is, that is minus 3. So here this is x3 x4. x3 x4 is minus 8, that is minus 4. This is here. this is x power square, that is 1. So here this is your matrix and this is column vector x1, x2, x3 and x4, which is equal to, so here this is the matrix notation of the quadratic form where A is your this matrix. So here write A equal to this matrix, here A equal to, here write down first is 1 minus 1 2 minus 1, here minus 1 2 2 minus 3 2 2 3 minus 4 minus 1 minus 3 minus 4 and this is 1. So here this is the matrix corresponding to this quadratic form Q. So here in this way you can write the matrix notation of the quadratic form. So so this is the matrix notation. So this is the quadratic form in 4 unknown x1 x2 x3 x4. So here matrix notation of this Q is x transpose Ax. Here number of unknowns are 4, that is x equal to x1 x2 x3 x4 x1 x2 x3 x4. So here x transpose is this row vector and this is the coefficient matrix. So here in the coefficient matrix first row is x1 fix, x1, that's why coefficient of x1 square, coefficient of x1 x2. Whenever you have cross coefficient I is not equal to j, divided by 2. Here coefficient of x1 x2 square, x1 x3 by 2, x1 x4 by 2. Here this is the cross coefficient, same a1 is same as a21. This is coefficient of x2 square, coefficient of x2 x3 x2 x4. In this way you can write the matrix. Then so with the help of this write the just coefficient, you will get the matrix notation corresponding to this quadratic form where A is the matrix corresponding to this quadratic form Q. So here with the help of this matrix, so after that, so once when they will ask the nature, at that time you have to find the eigenvalue of this matrix or sometimes a leading principle. So we can write this matrix notation. So whenever they will ask in exam, so write this matrix notation of the quadratic form is x transpose Ax. So with this we end up. Thank you.